All right, welcome back, everybody. So, in the previous video, we learned how to model a cantilevered beam in ANSYS, and I showed you how to set up the boundary conditions and assign the material property and create the mesh, and then create the stress results that we want, and even how to create a construction geometry so we can look at the stress. So now what we're going to do is we're going to compare these results to our hand calc. And now this is a simple loaded cantilever beam. But I have done the hand calcs. So just to go over some theory, again, if you remember from your statics class, you want to find the reactions of a cantilevered beam or any beam or structure that you're working on. You sum all the components, the x, y, z components equal to 0. So I've shown them here. So for Fy, I'll have F plus Ry, the reaction at the fixed support equals 0. And then you need to sum the moments about the fixed support and set them equal to 0. So we find that our y reaction is just going to be equal to opposite of our applied force, and our moment will be equal to the opposite of the applied force times the length. Now for stress, if you remember from your solid mechanics course, uh, our bending stress is my over I, where I is the moment of inertia. And this is the equation for the max shear stress as a function of y. And you'll see from this equation that it peaks in the middle. So as y goes from the outer edge towards the center, the stress will peak and then it'll go back to 0 on the opposite outer edge. And I've plotted them here. So these are the results that we should see on our linear or our path geometry and our linearized stress. And I've done the calcs for a 100-pound load and a 12-inch long beam. So we get a 100-pound reaction and a 1,200-pound inch force, or excuse me, a 1,200 inch pound moment reaction. And if you go through and do the stress calcs, our peak bending stress will occur at where x equals 0 at the far left of the beam at 900 psi. And our max shear stress will be 37.5 psi. So the first thing you should do really in your FEA is make sure that your reaction forces make sense. So what you can do is you can go in here and click Insert and go down to Probe and click Force Reaction. And then you can look at the reaction on your boundary condition. In our case, it was called remote displacement. And then right-click Retrieve this result. And ANSYS will show you the reaction force vector. And we see that it's 100 pounds in the y direction. And basically it's 0 for x and z. And the total reaction is 100 pounds. So that lines up with our calc, and that makes sense because we only applied a 100-pound load down in the y direction, or negative 100 pounds in the y direction. And then we'll look at our moment reaction. So we'll go in here and go to Probe, Moment Reaction, click Remote Displacement, right-click, Retrieve Result. And then again, we have 0 pound inches for the moment about the x-axis, 0 for the moment about the y-axis, and 1200 for the moment about the z-axis. And that makes sense. So now we'll look at the normal stress, and we see here that it lines up with our hand calcs, right? I mean, that's what we would expect. And if we look at the linearized normal stress, you can actually see here, we'll plot the bending and the membrane, and we'll take the total and membrane off. And at the outer edge of the beam, we're getting, 900 psi. and then it should go to 0 at the center of the beam. So right here at 1 inch, yeah, we see that it goes to 1 e to the -13th. So that's very small. So that's 0. So there's no bending stress in the center of the beam. And then the bending stress will be uh, the opposite. So the top of the beam is in tension and the bottom of the beam is in compression. And that makes sense. That compares very nicely with our hand calcs. And then we can look at the linearized shear stress. And yeah, we see that the shear stress is 0 at the outer edges and it peaks in the center of the beam, which is what we would expect. And it looks like peak shear stress is 35 psi, so it's a little less than our hand calc. And I suspect that the closer you take the shear stress towards the fixed support, the more of the strain influence you'll get. Again, because when you load this in the y direction, the top of the beam is going to want to pull away from the fixed support, and the bottom of the beam is going to push into the fixed support. So because there's a axial strain, you'll get a transverse strain. I think that influences the shear stress a little bit. But these are pretty good results compared to our hand calc. And yeah, and again, our max principal stress is going to be equal to our normal stress at the outer edge of the beam because there's no shear stress. And that makes sense. And as you see here, you'll get a peak stress where you apply the force load because we applied it on an edge. So those would, we would, you're doing an FEA analysis, you need to take into consideration some of these non-realistic stresses that you might get from your applied loads. But yeah, that's how you model a fixed beam in ANSYS, and we've interpreted the results and compared them to our hand calcs, and they agree nicely. So thanks everybody for watching, and hopefully you guys learned something, and looking forward to making more videos. Thanks.